All right, so quiz 5. So we started off with graphing. And so with our graphing, the first thing I was looking for was, does each graph have a title? Gave a point for each of those. If you're ever questioning what do I put down for a title, just look at the variables that you're plotting. In this case, you're plotting volume and mass. So you could just call for each, I would do it twice. You could just say volume versus mass. Just say each variable versus the other one. And you could have also, what was easy on these was to say you have a substance A for one graph and you have a substance B for the other. Okay? So that was the first thing I was checking on the graphs. And then the second thing I looked for was, did they label the axes? Label both axes. So on the axes, you should have labeled the x-axis as volume. And what's very important is that you put parentheses and indicate what units are being used. So in this case, the volume was in cubic centimeters. And then on the y-axis, we had mass, which was in grams. So both graphs should have had something like that. All right, the titles, by the way, should have been right above each graph. So I know what that graph is showing. All right, then I checked, did they plot the points right? Does it look like they plotted the points correctly? All right, so I checked each graph for that. Then I checked your best fit line. Now here's the thing about the best fit lines, guys. You got to think when you do these and do best fit lines, think about the origin. Okay, the origin is 0.00. It's 0 on the x-axis and 0 on the y-axis. What that would mean with this data is that if something has a volume of 0, it would have a mass of 0. Does that make sense? That if something doesn't take up any space, then it doesn't have any mass? I think that does make sense, okay? So that means our best fit line would probably go through the origin. So if I start from the origin and then go through the middle of my data with a straight line using a ruler, which I'm not here, obviously, but then I check the best fit lines. From there, what we had to do was we had to pick out any two sets of data along this best fit line so that we could find the slope. So when I'm finding the slope, I'm going to work my way left to right on this graph, the best fit line, which means I'm going uphill in this case, since the graph goes uphill as we go left to right. So I'm going to pick a spot somewhere on the graph, maybe here, whatever that is, and that's going to be my x1, y1. And then I'll pick another spot that's easy to read the data, and that's going to be my x2, y2. And when we find the slope, rise over run, which is really just going to be y2 minus y1 over x2 minus x1. And that's going to give us our slope, which I'd like you to try to get into a decimal. In math, you leave them as fractions a lot, which is fine. But here, I'd like you to actually do the division and get a decimal. So the way I had organized the data, and this is number 2, I'd kind of set up the data so that the slope should have worked out to be something close to, so this would be the first answer of number 2, should have worked out to be something close to 0.5, okay? And on the second one, the slope should have been close to 1.5, okay? So if you are anywhere close to those and your best fit line looked decent, then I give you credit. You might not have had exactly those numbers, but that's okay. Best fit lines sometimes vary from person to person. But I did use these going to number 3. What you put for slope, did that make sense with your for every statement? So here's what we do, and I saw some people that had paid attention to the review, watched the video, or just paid attention in class. It did a nice job of this, but they were so extreme about it that they went, what I'd said in the review was, if you take this number and just say there are, insert that number there, which is 0.5, there are 0.5, and then use your y units, and then say for every one x unit. And that would have worked, but some people wrote actually that. They wrote y units for every one x unit, when in this, let's be specific to the scenario. In this scenario, the y units are grams, and the x units are cubic centimeters. Okay, so it should have been something like there are 0.5 grams for every 1 cubic centimeter. And then on this one, same thing. There are 1.5 grams for every 1 cubic centimeter. Okay? And so what that helps us, the reason why we've been doing this is because it helps us understand density. You know, we've been kind of focused on density here. And if we look at that, that's really what it's telling us, is the density of these substances. And that comes into play later in the quiz. All right, so then we flip over. And I give you a couple new substances, substance C and substance D. And substance C, it says the mass is 10.8 grams and the volume is 4.6 milliliters, okay? And all density is mass divided by volume. So I just take the mass, 10.8 grams, and I divide it by 4.6 milliliters. And that came out to be like 2.34. I'm trying to remember. Something like that. According to the sig figs in these numbers, I should have just left it as 2.3. And then the units are just grams per milliliter. All right. And on for substance D there, we had a mass of 25.2 grams. And we had a volume of 75.3 cubic centimeters. So again, all we got to do is just divide, and that one came out to be like 0.33. Now in this case, the units, instead of being grams per milliliter, are going to be grams per cubic centimeter. Okay, because that's what I was dividing by, was cubic centimeters. All right, and then for the particle diagram, real simple. So back to what we used earlier for substance A and substance B. Okay, so here's substance B and here's substance A. All you got to do on these particle drawings to show differences in density is this. Change the spacing of the particles. That's all you've got to do, really. So according to the slopes and the for every statements we had earlier, substance A had a density of about 0.5, and substance B had a density of somewhere around 1.5, so substance B should be more dense. These should all be normal dots, by the way. And substance A should be less dense. Okay? And that is the review of Quiz 5.